Hello everyone, I am SJBIT, working as Assistant Professor in the Department of PC SJBIT. In this lecture, we will be discussing about computer organization and architecture.
So another first is the machine instructions in the program. So generating the memory address is how to specify the address of the branch target, and can we give the memory operand address directly in a single add instruction in the loop, or use the register to hold the address of the num1, then increment by 4 on each pass through the loop. So address modes. So why we go for addressing mode? The instruction set of computer typically provides the number of such method is called the addressing modes. So what is addressing mode? So the way which the location of operand is specified in an instruction, the way in which the location of an operand is specified the instruction, it is known as the addressing mode. So in addressing mode, the programs are use organization called the data structure to represent data used in the computation. So this includes the list or the linked list, arrays or queues and so on. So programs are normally written in the high level language, which enables the programmer to use the constants, local and global variables, pointers and arrays, where the translating in high level program it is necessary high level language program to assembly level. So the compiler must be able to implement these construct using facilities provided in the instruction set. So the computer in which the program will be run. So if we take for the C programming, we need the compiler C. So there are different ways in which the location of an operand is specified in an instruction referring as the addressing modes. So this is what the example in the summary they have given here in this table you are able to see. So this is what immediate addressing. The value is going to be considered as the operand is equal to value. The register addressing will be using the registers. So the operand is going to be RI, and absolute direct is nothing but direct location. Absolutely the particular location is going to be given here, that is the location. Indirect is nothing but it is kind of indirect addressing is specified by the RI. So the location of RI or the location of RI. Okay, so next it is the index addressing. So the X comma RI, so that is RI plus X will give the address. So the base with the index addressing. So base register is RI comma RJ is nothing but RI plus RJ will give the addressing function. So next is X of RI base with index addressing. That is RI plus RJ plus X will give the index addressing. Next is the relative addressing. That is the X of PC is equal to PC plus X. So auto increment is nothing but R plus, auto decrement is nothing but R minus. So these are the addressing modes: immediate, register, absolute, indirect, index, base with the index, base with the index and offset, relative and auto increment and auto decrement addressing. So the next we go for implementation of values and constants. So there are immediate mode, that is operand in the given explicitly in the instruction, that is move hash comma 200 comma R0 is nothing but the number is going to be moved to the R0. So register mode is nothing but the operand is the content of the processor register. The name of the register is given by in the instruction itself. There is move R1 comma R2, add R0 comma R1. So absolute mode is nothing but the operand in a memory location. The address of the location is given explicitly in the instruction. That is move LOK comma R1. Location content of memory should be moved to the R1. So next it is A comma R0. Indirect is nothing but the effective address of the operand is the content of the register or the memory location whose address appears in the instruction. Move R0 comma R1. So move add location with the parenthesis location R2. Okay. So this is going to be the addressing mode considering the indirect addressing mode. Add R1 comma R2 and the B it is stored the operand in the main memory, and the content of the B should be copied to the register 1. So this is what the true general purpose register. through the memory location, that is add r a comma r naught, which is been stored in the operand. That a will contain the operand b address and b is going to be stored the operand. So this is through a memory location. This is through using the general purpose registers. So next is the addressing modes, using indirect addressing in the program, as shown in here. So here if you are able to see that here the branch instruction will come here, branch is greater than 0, then follow the loop. So this is to add n numbers. So move n comma r1, move hash comma number 1 to r2. This is what initiation, clear r0, and the content of r0 is going to be getting 0 is getting added with r2. So if it is 16, the initial number 16 plus 0, next it is 16 plus 16, next it is 32 plus 16, in the so on. So add 4 times with the r2. So what is the loop is been created? It is for to add the 4 times. Every time decrement the counter. So here the number 4 is going to be, the R1 register is going to be activating as the counter. So until this add is for n number of times, so this loop is going to be executed. So after that the move the sum to R0 register. So next is the index mode addressing. The effective address of the operand is generated by adding a constant value to the content of the register. So we indicate the index mode symbolically as x of ri. That is nothing but x of ri is equal to effective address is equal to ri plus x. So the value of x defines an offset, also called the displacement, from this address to the location where the operand is found. For example, so move 20 comma r0 comma r1 is nothing but the location of r0 getting added with 20, that content is going to move to the r1. So in add 1000 comma r1 is nothing but the 1000 along with the memory content getting added with the 1000, that is going to be the memory location that is getting moved to the register R2. So the content of X may vary either an explicit number or as a symbolic name representing the numerical value. So if X is a shorter than the word and the sign extension is needed. So this is the addressing mode, that is the index addressing. So in the earlier example, we have told you that add 20 comma r1 comma r2. So is nothing but, so the location is 1000, that is getting added with the 1020. So the operand is stored here, that is getting added with the r2. So here you are able to see the 1000 getting added with the content of r1. Say the r0 content is 1000, the 1000 times it is getting added, that is the content of the R1 is 1000 and the 20 is going to be the offset, that is 1020 will be the operand and 20 will be giving as the R1 register. There are two types. One is the offset addressing, the other one is the offset in the index register. So this is going to be offset as a constant, here offset in the index register. Offset is going to be in index register. 1000 is the memory location, offset is the 20 getting added with the 20 and that is being transferred to the register. So next is the addressing modes. Consider a simple example involving a list of test code for the students taking a given course. So the 4-word memory block comprises a record that stores the relevant information for each student, and each record consisting of a student identification, number ID, and followed by the scores of the students earned on 3 tests. So this is what the diagram. So list of the students, that is n number of students, list student ID, test 1 is list of plus 4 and the test 2 is list of plus 5 and the list of plus 12. So totally it is regarding for the student 7. So next memory location is for the next students. Similarly it is going to be allocated for n number of students. So this is regarding. So here we are able to see that, so the first, so assume that the list of the score is beginning of the list, list, as shown in this figure. So 4 memory consisting of a block of comprises a record and that stores the relevant information for each student, and each record consists of a student identification number followed by the scores student earned on 3 sets. There are n number of students in the class. The value of n is stored in the location of capital N immediately in front of the list. So the address given in the figure for the student ID and the test score assume that the memory is a byte addressable, and that is the word length is of 32-bit. Word length is of 32-bit. We should note that they represent two-dimensional array having n rows for columns, and each row contains the entires of one student, and the column given as the ID and the test score. So this is the second example where suppose we wish to compute the sum of all the score obtained in each of the test, to store these sums in the memory as sum 1, sum 2 and sum 3. So during that time, a possible program task as shown in the figure, the earlier figure what I have shown, that is in the body of the loop, the program uses the index addressing mode to access each of these three scores in a student record, and the register R0 is used as the index register. So before loop is entered, R0 is set to point and the ID location and the front student record, and thus it contains the address and the list. So on the first pass through the loop, test score and the first students are added, and the running sums are read in the register R1, R2 and R3, which is initially cleared to 0. These scores are accessed using the index addressing, that is 4 of R0, 8 of R0 and 12 of R0. So the student register R4 is initialized to contain the value of n, and it is decremented by 1. At the end of each pass through the loop, when the content of R0 reaches 0, all the student records have been accessed, and the top terminates until the conditional branch instruction control back to the smart loop processes and the next record. So the last three instructions transfer and accumulated sum from the R1, R2, and R3 into memory location sum 1, sum 2 and sum 3 respectively. Thank you.